Welcome to Ask and Learn.
Hi there. In this question, we have 3 oxidation-reduction reactions, and we have a series of questions to answer for each one. So let's get started with the first one. The first one, we have aqueous silver ions reacting with solid lithium to produce solid silver. And lithium ions that are aqueous. So the first thing wants us to balance this equation. So this equation is already balanced as written. The next thing, we need to use Appendix C to calculate the standard heat of reaction. We do this by taking the heats of formation for the products and summing those together, and then subtracting the heats of formation for the reactants added together. Remembering that when we're doing heats of formation, elements in their natural state have a heat of formation of 0. So that means in this particular problem, the solid lithium and solid silver both have heats of formation of 0. So it's a matter now of taking the products and subtracting the reactants. So we need to look up the lithium ion. The lithium ion's heat of formation is negative 278.5 kilojoules per mole. And then we want to subtract the heat of formation for the silver ions. And Appendix C tells us that that is 105.90 kilojoules per mole. So completing the calculation here gives us negative 384.4 kilojoules. Notice it's a negative sign, so that is exothermic. So part C wants to know, is this favored thermodynamically? So since it's exothermic, yes, it is favored. Remember, everything is striving to get to its lowest energy state. So by releasing that energy, the overall energy has been lowered. So this is favored. And then the last question wants us to, or the last part of the question wants us to look up the activity series and see if my answer to part C goes along with what the activity series says. And when we look at the activity series, lithium is more reactive than silver, or has more activity. It's higher on the activity series. So yes, these two agree. So we do have agreement between part C and part D. All right, let's move on. And of course, this was our answer for part B. I'll go ahead and circle C and D also. All right, let's move on to our second equation then. In our second equation, we have iron, which is elemental in its solid state, reacting with sodium ions, which are aqueous. And it says that this is producing aqueous iron ions with a +2 charge, plus elemental sodium. All right, we do need to balance this. It's an oxidation-reduction reaction. So since iron lost 2 electrons, means we have to have 2 sodium, so each one can accept one of those 2 electrons for a total of 2. So that is our balanced equation. Part B, we need to calculate the standard heat of reaction. Remember, we have to take the products and subtract the reactants. But again, the elements have a heat of formation of 0. So this becomes a matter of taking iron, which is, the aqueous iron has a heat of formation of negative 87.86 kilojoules per mole, and then subtracting 2 times the heat of formation for the sodium ion, which is negative 240.1. Calculating the answer here gives us a positive 392.3 kilojoules. So we see a positive sign here. So that means that for part C, this is not favored. It is endothermic. And for part D, the activity series supports this. Because sodium is actually higher than iron. So it's more reactive. So both C and D suggest that this reaction is not favored. And they are in agreement with that. All right, finally, we have one more reaction here. We have, let's see, solid potassium. So elemental potassium reacting with liquid water to produce KOH, aqueous, plus hydrogen gas. All right, to balance this, I am going to need to add, let's see, a 2 here, and then I would require 2 potassiums and 2 waters. So now there's 2 potassiums on both sides, 4 hydrogen, and 2 oxygen. So this is now balanced. Moving on to part B. Part B, calculating our standard heat of reaction, or enthalpy of reaction. We only have one product to be concerned with here because, again, hydrogen is the element, so it is going to have a heat of formation of 0. And similarly, potassium. So we need to look up KOH, and there are 2 KOHs. So 2 times negative 482.4 kilojoules per mole. And then subtracting, looking up liquid water, 2 times negative 285.83 kilojoules per mole. Grabbing our calculator and calculating this, I get negative 393.1. So we see a negative sign there. This is exothermic. So for part C, exothermic, so yes, it's favored. Oops. And when we look at the activity series, guess what we find there? The activity series agrees because we see that K has more activity than the hydrogen. So we have agreement between C and D. Actually, B, where we calculated the negative in the first place. But we do have agreement. All right. A little bit of a long question here, but I think we got through it. And thanks so much